Hello, folks. This is the assignment one for the lab group on Friday afternoons. There are two problems here, and I will do both of them for you. Let's worry about the first one. Uh, you're given a part here with the dimensions, and then you're told that the inside of this circle is whole. This inside of this hole, in, inside of this hole is clamped, and then you're applying a pressure there. As in all the problems on your test, you're given some instruction. Use all planes of symmetry that are applicable, if any, and use the most appropriate element. In this case, we have only one type of element that we have introduced, that is only solid elements, tetrahedral element, linear or parabolic, and then make a finer mesh around the hole. Okay. Now, as far as planes of symmetry is concerned, this inside is completely clamped. Inside the hole is clamped, and then you're applying a pressure here. So it just compresses, and you can see that. Hopefully you can see that, and gradually you will develop the skills for it. That X, Y is a plane of symmetry, and Y, Z is also a plane of symmetry. Okay, so I'm going to create this model in its entirety, and then I make the appropriate cuts and save it with the proper name to two planes of symmetry, and then we run the analysis. Okay, so let's go ahead and do that. The different strategies for doing this problem, I'm not suggesting that you follow mine. As long as you can make this part as it's supposed to be, this is fine. So let's start with the part file. And immediately I'm going to save this thing. So we go to File, Save Management, Save As. On my desktop, I'm going to create a folder, desktop. On my new folder, and over here I'm going to say assignment 1. Assignment 1, and the name of it, the name of this file, I'm going to call it uh, problem problem 1. How about afternoon lab, and two planes of symmetry. Two planes of symmetry. Okay. All right. Let's go make it. So on the vertical plane, I'm going to sketch something that looks like this. I'm going to dimension it in just a minute. On principle, well, on purpose, I'm going to do it like that. So first of all, let's clean it up. Top line, control bottom line, control the middle axis. Let's go to constraint define in a dialog box right above the dimension, and I say symmetry, cleans it up. That automatically puts that circle on that. If we are not 100% sure, we can say this control with that tangent. Oops. Constraint define a dialog box tangent. Yeah, and automatically it's going to put that circle, of course, the center of that circle on that line. Oh, this one has to be vertical. Right click. You can either do a right click vertical, or we can select this and go to that same dialog box and say vertical. Okay, good. Now we put dimensions. So the dimensions are, let's see what we have here. This is 10. Okay. The radius is 4. This is 4 inches. Okay. And there's a little circle here inside. that circle, and the radius of that circle, according to drawing, is 1. 1. All right. Exit. Where is the exit? Oh, right there. And pad it symmetrically. That means mirror extent. In each direction, that one is 1 inch, a total of 2 inches. So, but when you check this thing, you have to put a 1 there. Okay, good. Now, on that face, I will sketch. As I said, there's so many different ways of doing this. Actually, changing my mind. Let me do it on this face. I will sketch. Fit. Right there. That's the end. So we have a rectangle which is 8 inches high, obviously, and 6 inches wide. So let's do it like this. Any one of us will have our preferred way of doing a problem like this. So I will leave it to you to decide. This is 6 inches, I believe. Yeah. Okay. And of course, these two, why don't I, let me make this coincident with that. Bring it down, basically. Or dimension between them 0, either way. Okay, because it was symmetric, it's already both sides. Very good. So exit. And then we pad it by 1 inch. There we are. So this is my part. Now, first of all, let me save this. There. I'm going to make 2 cuts. So here's a split. One with this plane and one with that plane. There we are. So this is 1/4 of the model. We're going to make it out of steel. The instruction was that make it out of steel. Okay, with default material properties. So there, and save it. Excellent. Okay, now we're going to go to generative structure analysis. Incidentally, it immediately creates an analysis file and meshes it automatically. Let me change the rendering here. Okay, but I'm going to save it. Okay, file, save management, analysis, save as, and I'm going to call this analysis 1, but is associated with the problem that we just, problem 1. Afternoon. I should have copied and pasted that name. And 2 planes of symmetry. 2 planes of symmetry. Okay. And we say okay. So let's read the instructions. Planes of symmetry, obviously we have 2 of them, so we put them on surface slider. So there is one, there is another one. This is the bottom plane completely. And then there's the back, because we cut it there too. And we can do that separately, or we can do it in the same, did it do it? I don't think it did. Let's do that last one. How many planes, how many surfaces here? 2 planes. Okay, so I could have selected this one too. Right, three faces. Good. If you want, you can put them in separate ones and then give them an appropriate name, etc. Now this N is subjected to a pressure of 50, psi. Remember, this pressure, you don't divide anything, you just leave it. If it was 50 pounds, then of course you would take 1/4 of that. But this is pressure, you don't do anything. Okay, you're told that the inside of this hole is clamped. There you have the entire inside surface, inside face. So you got it on the edge, but then you're not following instructions. It says the entire face of that hole is clamped. Now, there's one other thing that we should do before we finish this thing, and it says make sure that the mesh around the hole is finer. Okay, so we know how to do that. We're going to go to local mesh size, and select that face, and it puts the size that element that size compared to this. If it's an overkill, just leave it the way it is. That's fine with me. Okay, so we save this thing and we run it. I'm not sure what the element type is. It's probably parabolic because when I did the earlier video, it was parabolic, and it stays like that unless you change it. In the absence of any instructions, do either one. This message always pops up for these type of problems, for solid problems, for different reasons, not critical. And look at the deformation. That's the way it should be, right? Okay, good. If you want to look at the stresses, change the rendering here. Oops, material. There we go. If you want to see the mesh for any reason, then you have to ask for it. And the way to do it, you go to rendering, and down here there's a question mark. You click on it, and yeah, you get the mesh. And then you can look at the displacement and things like that. But that's pretty much it. As far as problem 1 is concerned, this is done. So let's go to problem 2. Problem 2, and let me close this. I don't need this. I'll keep the part here for a second. Problem 2 is exactly the same geometry, except that a load is applied on this side. If a load is applied on this side, I'll let you stare at this thing, think about it, etc. One of the planes of symmetry is gone. The YZ plane of symmetry is lost, but the XY is still on. So I have to delete the YZ plane of symmetry so that it's just half of the model, not 1/4 of it, basically. So let's go ahead and do this thing. So there are two planes of symmetry. One of them we're going to this one we're going to delete, and because I changed the part basically, and I don't want to overwrite the old one, I'm going to save this thing with a different name. So File, Save Management, Save As. Not two planes of symmetry, we say one plane of symmetry. One plane of symmetry. One plane of symmetry. Okay, good. Oh, this was I should have called it problem 2, but that's okay because I changed the name. I was lucky. So let me actually do this just so that I'm completely organized. I'll call it problem 2. Afternoon, one plane of symmetry. Very good. Okay, good. And I can even close this. But I'll leave it up. So we go to generative structure analysis. And why don't I save this thing right away? File, save management, analysis, save as. Okay, just be careful here. So this is going to be problem 2. Problem 2. Afternoon. One plane of symmetry. The only reason I'm so fussy about these things, I don't want you to hurt yourself on the test, overriding your files. Okay? And then you say, okay. All right. So, I can't remember what was the loading in this particular problem. It was on the side, but it was also pressure, so I don't divide pressure on that side. So let's go ahead and apply our pressure. Pressure on this side, 200. Yeah, okay. Inside of this thing was clamped. Okay. There's a surface slider at the bottom here. Here there's a surface slider. There's a surface slider. And this takes care of that piece also. You can see that. All right. And oh, you're also told to make sure that there's a fine mesh around the hole. Okay. So we're going to go to the local mesh size. Turn this thing around. It says where. As soon as I pick this surface, it puts a smaller mesh there, right there. See that this compared to that green thing, this little green element compared to this big one. And if you want to change this thing, make it smaller, make it bigger, etc. We don't care because we just want to make sure that you know how to do it. Okay, let's save this. It's already saved with the proper names. All I have to do is to click on the floppy and then go run it. Hopefully we didn't forget anything. I don't think we have, but there we are. You never know. Always praying help. Praying helps. It helps. Okay. Well, this is standard warning that you're going to get for these type of elements. Of course, they may have taken that away in the newer releases, but sorry. So deformation like that, that's what you expect. Yeah, if you want to make it faster, if you want, you drag this thing, go faster. Not much faster though. Okay, you want to find the stresses. Remember, we are not assessing accuracy right there. And the deflection, if you want to look at the deflection, these are very small stresses because, you have a very thick steel piece and you're putting some kind of a small load, tiny load on it. These are extremely small, for thousandths of an inch. That's pretty much it. So good luck.